Thank you everyone for joining us today on our webinar, The Future of Edge Kubernetes, where we'll discuss how to deploy and manage edge environments at scale. My name is Saad Malik, and I'm the CTO and co-founder for Spectral Cloud. Joining me is Jana Kiram, a prominent industry analyst and advisor. Johnny is an established thought leader in an industry and frequently blogs and writes and shares his thoughts about Kubernetes, edge, and related technologies. Johnny, it is a pleasure having you here on our webinar.
Thanks, Art. Excited to be partnering with you.
Awesome. And so everyone, before we get into the content, if you have any questions, feel free to post them using our Zoom webinars question section. We'll answer the questions as part of the presentation, and time permitting, we'll also host a live question answer session towards the end. So Yanni, over the last decade, we've seen how organizations are leveraging digital transformation and application modernization to really deliver experiences to their customers, to their employees. However, over the last couple of years, we're seeing a big push towards providing these applications experiences in edge environments, right? And we're seeing this across all different industries. We're seeing this across all different verticals, whether it's from restaurants, retail, healthcare. What do you think is driving all of this?
Right. So, in the last decade or so, we have seen a lot of adoption and uptake in the rise of cloud computing. A lot of enterprises and even small and medium businesses, startups, everyone started to embrace public cloud, and cloud has become the extended data center. But if we actually look at cloud, it's like a huge mainframe. You are basically connecting to this centralized location from various locations, and you are consuming resources offered by hyperscalers like Microsoft, Amazon, and Google. While it is very, very economical, cost-effective, and efficient in consuming the public cloud, there are scenarios that are not ideal for cloud. And the more you try to migrate your data center and workloads to the cloud, the more important it becomes to create a layer in between the cloud and your consumers or the devices. So just like history repeats itself in the fashion industry, we are now seeing another trend where it's not all about centralized compute resources, but you may need a layer in between the cloud and the consumers and the devices. So when you bring this conduit, when you bring this middleware, if I may, it is going to mimic or extend the capabilities of the cloud, and it addresses certain challenges that are typically available with the cloud, like latency, privacy, compliance, and even pre-processing data and cost management, because not everything can move to the cloud and not everything should move to the cloud. So what do you call that layer which is sitting in between the applications, the consumers and the devices and the public cloud? That is the new layer, which is called the edge compute. So edge compute mimics the public cloud, extends the public cloud while delivering local offline capabilities to applications and devices.
Yeah, absolutely. And the other aspect, though, is you talk about this cloud. Can you talk a little bit more about what is powering the cloud now? We're seeing a big push of these applications that are being powered on the cloud. What does the next generation of these cloud computing look like?
Absolutely. One thing that is taking everyone by storm is the move towards containerization and the adoption of Kubernetes. So let me step back a little and tell you where it all started. So the first version of cloud was all about virtualization and VMs. For example, Amazon EC2 was based on Xen, Google Compute Engine was based on KVM, Azure was based on Hyper-V, and everyone thought spinning up virtual machines in the cloud is super cool and very cost effective. But VMs are very heavy and they are not really meant to run in the cloud, as in they were not designed to take advantages of the inherent capabilities of cloud. So last 5 years or so, we have seen a new mechanism of deploying applications, and that is through containers. So containerization has replaced, or it has become an alternative and a more efficient form of virtualization. And one of the proof points for that is almost every public cloud provider now has a managed container offering, container orchestration offering. And what is common across all these managed container orchestration services is Kubernetes. So when you have more than one container to manage and orchestrate, you need a layer to do that. And that is almost like the new operating system. Just like the operating system manages the processes, you need a new operating system to manage these containers. And that operating system to manage containers running in the cloud and data center is Kubernetes. It is taking over the software world. It is almost like the new Linux. It is getting as much popularity as any other Linux distribution. And almost every hyperscaler, you name it, has a managed offering of Kubernetes. So this is actually driving a lot of modernization and helping customers and enterprises in delivering digital transformation. So when you look at how customers are modernizing their apps, it is basically moving from monolithic virtual machine-based applications to more of modular, contemporary, containerized microservices. And at the front and center of this modernization mechanism is Kubernetes. So this is becoming the most important aspect of software.
Yeah, and Yanni, I'm sure you can remember just 7 years ago when containers was becoming really popular, we saw this plethora of different container orchestrators, everything from Mesos to Cattle to Nomad. But then Kubernetes came aboard, and within 2 quick years, almost every enterprise decided that Kubernetes is going to be the de facto container orchestrator. I think what it does so well is providing this abstraction layer for your compute, your storage, your networking to be able to run it inside of any environment. And alongside with it, for every enterprise application, it provides capabilities like auto healing of your applications, service discovery, and many things like secret management and state storage. This is the reason I think it became so popular so quickly, is that instead of enterprise teams having to build all of this functionality themselves, they could just leverage Kubernetes to provide all these capabilities across any environment that they want to do.
Absolutely. They could very quickly reach the reliability, self-healing, and some of the capabilities which were exclusive to the public cloud providers.
Oh, exactly. And so as part of our actual research into Kubernetes, we sponsored a service from Dimensional Research that looked at how 160 different customers in production are leveraging Kubernetes. And what they found is today, over 78% are leveraging multiple different environments, whether it's clouds, data center, or bare metal for running Kubernetes. And we're going to see that this adoption of Kubernetes is definitely going to increase. Today in production, right, containers are only around 30% or so, but the assumption is, or the prediction by Gartner is that by 2025, that 85% of organizations will have containers in production. So we're going to see adoption of Kubernetes also experience very, very high growth.
Absolutely. Where VMs failed and where public clouds couldn't really deliver on the promise of hybrid cloud and multi-cloud and extending the data center to the cloud seamlessly, that is now the promise of Kubernetes. And both the providers and the consumers are able to realize their potential. Absolutely.
So, Johnny, you talked about edge requirements before, and then we talk about Kubernetes becomes the de facto standards for cloud and data centers. Are we also starting to see edge Kubernetes?
Absolutely. So it's actually a journey. If you look at containerization, it was initially confined to the public cloud. Everyone targeted a managed Kubernetes offering. And then came in distributions that were exclusively targeting the data center, like OpenShift or VMware Tanzu and so on. And then Kubernetes found its place in the data center. But the newest trend and what actually makes more sense for some of the modern applications is this edge, where you actually run the local data processing, the local device management, and a lot of capabilities that are originally available in the public cloud, but now becoming more and more offline and running environments closer to the applications and devices. So when you run this, it doesn't exist in vacuum. It needs the same layers of technology that is run within the data center. Edge is like a miniature form of compute, storage, and network. It's not an exception. It is not anything different. So obviously, when you have this, you need a very small footprint. You need manageable units of deployment. And what else is better than container or a set of containers to run at the edge? And guess what? The moment you have more than one container, Kubernetes becomes more and more critical, because you don't want to manage containers by all by yourself. You need Kubernetes to orchestrate those containers, even at the edge. So it's a no-brainer that Kubernetes is becoming the most preferred, almost like an operating system, to run the entire edge stack. Because remember, edge is also the same compute, network, and storage, and it is running a set of containers. And what else is better than Kubernetes to manage that? So obviously, Kubernetes is finding its way to the edge, and it is becoming more and more prominent and almost the only choice to run edge computing layer.
Yeah, and frequently, I'm sure you're seeing in the field where all of these edge projects are also leveraging some aspect of cloud, whether you're doing data analytics or inferencing or even point of sales aggregation. At the end of the day, all of this data in maybe a very small form factor, very small data, is sent back up to the cloud environment. Now, if enterprise teams are already leveraging the cloud for Kubernetes and essentially building their container applications there, you'd want to use the exact same stack that you already built familiarity with your developers and operations teams also on the edge. And like you mentioned, Kubernetes does provide a fantastic abstraction for compute, storage, networking, whether it's on the cloud or whether it's on this edge. And surprisingly, what we're finding is that even today, with edge being relatively new, that 1 of 3 Kubernetes in production are using edge today. So there's 1 in 3 deployments are actually in edge Kubernetes. It's a very, very fast growth.
Absolutely. For example, they can use the same Helm charts. They can use the same CI/CD pipelines. They can use their proven automation tools, infrastructure as code. Essentially, everything that's been working well in the data center and cloud environments can be seamlessly extended to the edge, because there is a common fabric across the cloud, data center, and the edge, and that is basically Kubernetes. So as long as you have Kubernetes, you can take advantage of all the investments you made in automation, Helm charts, customize, GitOps, and whatnot. So it is becoming the common fabric and the lowest common denominator.
Yeah, perfect. Let's talk about some of the more common use cases that you're seeing, Yanni, right, with Kubernetes, at the different edge.
Absolutely. This is one of my favorite topics, and I'm going to spend a little longer on this slide on this topic. Awesome. So what actually drives edge? There are 3 horizontal scenarios and use cases that are common to almost every vertical that you see on this slide. The first scenario is data processing and data pipelines. So today, it's a cliche to say, but data is the new oil, right? So there is data everywhere. Elevators to microwave ovens to refrigerators, everything is generating a lot of data. But you don't want to send all that data, which also has a lot of noise, to the cloud. It's more expensive. The bandwidth is going to be choked, and you don't need all of this data to flow into the cloud for various reasons. In the scenario of healthcare, you definitely don't want to send highly confidential and private data of patients to the cloud. You may want to anonymize it. You may want to do something with the data before you send that to the cloud. So edge becomes that layer where you perform the signal to noise ratio conversion and send only the required data to the cloud, and also perform pre-processing of data. For example, I know an automobile vendor who is venturing into autonomous vehicles, driving their cars with the 3D cameras and LiDAR sensors on the streets. And these cars that are capturing a lot of data come back to a station, which is actually an edge, and they upload all the data that they have captured. And that data is actually going to be labeled by humans, and then it is moved to the cloud for training a model. So it is going to identify pedestrians, it's going to identify cyclists, it's going to identify street lights and all of that. And then at the edge, there is some kind of an automatic labeling and manual labeling, and then it is sent to the cloud for training. You cannot bypass this process. That is where edge comes into the play. Data pre-processing, data pipelines, and running all the conversion of data to reduce bandwidth, achieve compliance, make it more secure. It's all about data. So data pre-processing and analytics are the biggest drivers of edge, number one. Number two, it's all about industrial automation and IoT. So, today, IoT is no more a fancy mechanism. It is becoming very real. It is becoming the backbone of a lot of manufacturing units, a lot of automotive companies. So in IoT, there are two very important aspects. Number one is the machine-to-machine communication. For example, a very simple scenario of the thermostat getting controlled when the temperature reaches a specific threshold. So when the temperature sensor sends a specific data point, if it crosses a threshold, then the thermostat needs to be adjusted. So who is going to orchestrate this? Now, you cannot obviously send the HVAC data or the sensor data every second or every 30 seconds to the cloud and then come back and control the thermostat. You need to run this logic, this rules engine locally. So that is very important. And where does that run? Obviously, that's the edge. So these rules engines and the bridge between sensors and actuators that are orchestrated is going to be running at the edge. That is one of the very important use cases in the IoT scenario. The second one is basically the telemetry ingestion. So these sensors generate a ton of data. And obviously, as we discussed earlier, you don't want to send this data in its raw form to the cloud. So you want to pre-process, you want to apply some logic. So both the M2M, which is machine-to-machine communication through a broker, and telemetry ingestion and pre-processing is another important use case of edge, particularly in the industrial automation scenario. The third one is huge, and we see that everywhere, and that is the AI inference. It's very clear that the public cloud is meant to train the models, but the inference, which is the second life of a model, takes place at the edge. So you take a lot of data, train the model in the public cloud, but once the model is generated, it is going to be deployed at the edge, and then it is going to perform inference. For example, in a typical quick serve restaurant scenario, there are cameras set up on top of each table, and these cameras send the feed to an AI model running at the edge to figure out if the table is dirty or clean, and it generates a heat map saying what is the table that needs to be attended and cleaned in real time. So obviously, if you're running an AI model to classify a table to be clean or unclean, you can't run that in the cloud. That model needs to run somewhere within the restaurant, however small it is. And it's a great use case and a candidate for edge. So to summarize, across any industry vertical, across any industry environment, these are the three driving forces. Number one is data pre-processing and data pipelines. Number two is IoT and industrial automation. Number three is ML and AI inference. These are the biggest and the key drivers of edge.
Yanni, and I think you covered all three perfectly in that we actually have a customer, GE Healthcare, that is across all of them, right? Everything from IoT devices to have saving on bandwidth and doing inferencing. So GE Healthcare, as you're aware, is the leading manufacturer of healthcare diagnostic tools and equipment. They build everything from MRI machines to CT scanners to smaller IoT devices like your heart rate monitors, your oxygen saturation level devices, blood pressures, et cetera, you name it. Everything that could be life-saving devices. So GE Healthcare is also building the modern applications which interface with these devices, whether it's your MRI machines and CT scanners to all the way from your heart rate sensors and your blood pressure sensors. It's not economical to send all of that data back up to the cloud to do processing. One, it's very costly. And number two, if there are intermittent connectivity issues at the hospital or something else, you can't afford to have any downtime because of external issues. For this reason, they're leveraging our platform to be able to deploy and manage Kubernetes along with their application stack that interfaces with all these different systems. Specifically for the MRI machines and the CT scanners, they're actually scanning the actual gigabytes of the image data that comes out. The DICOM data is huge. And one, they're doing local inferencing to detect for tumors and cancer. And two, whatever the results are generated, they do dupe all the privacy information. If you have your social security number and your information about your patient, they remove all of that before they send a aggregated result back up to the cloud environment so that nothing is traced back to a single patient or a user. So everything you mentioned, I mean, this is what we're seeing today in healthcare industries across the field, from retail, restaurants, oil and gas. We're seeing very similar use cases. So
absolutely.
Yeah. So obviously the promise is big, Yanni. You know, Edge, if you can deliver on it, it would be fantastic. But what are some of the biggest challenges you see with Edge?
Yeah, this is a very, very critical aspect, and we should absolutely discuss this. So one of my observations are is customers don't know what they don't know about Edge. So it's a blind spot. For whatever it is worth, you know, the hyperscalers have turned Kubernetes into a push button based deployment. Customers who are used to dealing with Kubernetes on Google, Microsoft, or Amazon Cloud assume it is going to be as simple as pushing a button, provisioning a cluster, and then using kubectl to deploy an app. But what they don't understand is running Kubernetes at the edge is a completely different ballgame, and it is going to be like playing the Minesweeper game. You don't know what you're going to step on and what's going to explode. So why is it so complex? And what are the points that customers typically miss when it comes to Kubernetes on Edge? First of all, Edge in itself has certain attributes and constraints. Number one, Edge is going to be run in a highly constrained environment where connectivity is not guaranteed. It is going to run in very harsh environments, like next to a large furnace or in a windmill. Third thing is you don't have certified administrators and Kubernetes administrators to manage the infrastructure. It is going to be running in an environment that is prone to failures. So that is something that is obvious about any edge. Forget about Kubernetes. Now, to this mix, to these constraints, when you bring Kubernetes, the complexity becomes 2x. Why? Because unlike the public cloud, there is no managed edge. For example, when you're running a Kubernetes cluster in the cloud, a lot of decisions are made for you that you don't have to deal with. For example, what kind of a network interface, container native interface are you going to run? What kind of storage layer are you going to deal with? And what about observability? Do you run FluentBit or FluentD? And where do you host Prometheus? All these questions are answered and handled by the public cloud provider, and it becomes almost like a black box. But when it comes to edge, customers will have to make the decision all the way from the operating system to the topmost layer, which is observability. And they are completely on their own. A simple decision or a trade-off can make or break the entire stack. For example, choosing an operating system that is very heavy but easily manageable will have an impact on the overall performance and the overall responsiveness of the stack. Choosing a lighter weight operating system might come with its own challenges. And then choosing the distribution. There are 24 distributions of Kubernetes out there. What is good for me? There is no single answer to that. And then how do I choose storage? How do I choose network? Then, that is the first problem, basically stacking up all these layers and making sure I have a trusted and tested stack to go with, number one. Number two is the day two operational challenge. And remember, when you're running edge, you're running a fleet of edge devices. It is not a single data center or a single location. You're running it across continents, you're running it across countries. So tomorrow, suddenly, if there is a 0-day vulnerability announced on the operating system distribution that you're running, imagine patching 10,000 locations by overnight. Now, that is not going to be easy. Similarly, performing an upgrade, Kubernetes has an aggressive cadence. Every 6 months you have a new version of Kubernetes, and you got to catch up with that. You got to do that, if not every 6 months, at least once in a year. But doing that across these many locations is not going to be easy. And then when you are assembling your stack with a mix and match of open source and commercial, every other week you are going to upgrade and manage one of the components that run in your stack. So day 2 operations is a huge blind spot that customers overlook till they hit that pain point. So to summarize, you have 2 highly complex factors which cannot be overlooked. Number one, edge by itself is highly constrained. And second, you're running another complex software stack based on Kubernetes and containerization. And bringing these 2 together by no means is meant for faint-hearted. You need to make a lot of decisions right to roll this out and to get it right. Whether you're a CIO or a CTO, your career depends a lot on what you actually choose and how you assemble your stack, because this is really a make or break decision for your edge strategy.
Yeah, absolutely, Yanni. I think you covered some of the key points here. One is, because there is no managed Kubernetes, you are selecting and responsible for each and every one of the integrations and its lifecycle, keeping them up to date. Many of these integrations don't even work well together. How do you ensure that they continue working together, not only the initial provisioning, but even during updates? The other big aspect that you already covered is you don't have highly skilled personnel at these edge locations. So if something breaks, you wouldn't expect the store manager of McDonald's to be able to log into the box and fix anything in Kubernetes, let alone Linux or anything like that, right? So it needs to be completely resilient and always operational. And by itself, a single Kubernetes, whether it's cloud or edge, is very complex. Can you imagine now managing hundreds or thousands of locations, right? And also having the policies to selectively do updates across different stage environments, your production environments across different regions. There are just so many different aspects that organizations who are looking to deploy edge have to think about. So.
Absolutely. So I tell my customers to look at the Kubernetes cluster running at the edge like a set-top box.
Yeah.
Just like you don't fiddle with the set-top box, you plug in, you power it, and then you switch on, it works. So for all practical purposes, Kubernetes at edge should be reaching a stability point where customers can almost treat like a set-top box and not a set of computers.
Absolutely, absolutely. And I think part of that, the research that we did with dimensional research identified some of these challenges. One was a number of integrations and managing it. How do you do that? But for the end user, keeping the operation as simple as possible. The other aspect that everyone is really concerned about is providing security. Many of these edge devices are going to be unmanned in environments that there are no people, right? And whether it's a malicious user tampering with a device or it's accidental config drifts over time, how do you make sure you prevent that? Not only for the Kubernetes layer itself, but even for the application layers on top of it. Just out of curiosity, but what are some of the other challenges that you see that edge Kubernetes projects either have gone through or will go through over time? So.
Two very important aspects. Number one, something that we see here, which is the bare metal. Now, you cannot ignore the fact that you don't have virtualization. You cannot simply rip and replace a VM with another VM which is working. Bare metal is a beast that no one understands how complex it is, particularly when you're running Kubernetes. That is number one. And number two is, again, basically the day-to operations, which is also showing up here. So those are two critical aspects that are actually coming in the way of mass adoption of Kubernetes at the edge. The bare metal thing, whether it's an Intel NUC or a Jetson Nano kind of a device, and then performing the scale. And the third thing is fleet management. Today, customers have, as you said, tens of thousands of clusters running everywhere. Now, how do they get visibility into all these clusters from one window, a single pane of glass, and basically identify which store or which restaurant is currently facing an issue and proactively fix that? So fleet management is the third one, which is very important. So interestingly, that is the direction that the industry is taking. These are some of the hard problems that the cloud native ecosystem is trying to solve. And I know Spectro Cloud is one of them who is very keenly focused on this.
Yeah, absolutely. And if you're interested, Yanni, I'd love to kind of show you some of the areas that we've been improving, providing capabilities in terms of providing easy access for any organizations to deploy and manage, including the day-to operations for this edge environments. So,
cool.
Yeah, let me go ahead and share my screen again. Give me 1 second. And then let me know if you can see my login screen and this little guy that's going up and down. Yeah, awesome. So Spectral Cloud, for everyone who doesn't know, we are a Kubernetes management platform. We help organizations to deploy and manage Kubernetes in any environment, right? Whether you talk about from public cloud, private cloud, data centers, and of course, also edge environments. So as you can see here in my actual environment, I have clusters that are running across my AKS as a managed Kubernetes. I have Google, GCP, VMware, I have OpenShift, every single environment you can think about. And from our perspective, it's about being able to not only provision and manage the clusters, but also providing health and visibility right across all of these different environments.
So, Saad, what I actually see is there are a lot of Kubernetes clusters that are showing up in a single console. And this almost reminds me of Google Anthos or Azure Arc or VMware Tanzu Mission Control. Is it very similar?
There's aspects of it which definitely are similar in that we both help to manage and provision lifecycle. But where we are a little bit differentiating is for us, it's not just about the core Kubernetes layer. We realize that Kubernetes is about having all the different integrations and services built into it. Everything from your logging, your monitoring, your security, all the different areas of technologies that development teams and operations teams need to be able to manage. And so what we do is called full stack management, where you can model the entire construct into a blueprint or template that we call a cluster profile. So for example, Yanni, I'm going to go into an existing prod VMware cluster profile and show you that not only from the operating system Kubernetes that the other solutions do manage, we're able to manage the entire stack on top, from your load balancer, service mesh, ingress, logging, monitoring, and more. Out of the box, we have around 50 plus different integrations from any one of these different layers. And each of these different integrations have been pre-tested and pre-validated across every version of Kubernetes that we support. And we make it very easy if there's an integration that you don't see that we offer for you to be able to upload your own components, your own integrations, and still be able to model it as part of the stack.
This is very interesting. Actually, what I like about this is the visual representation of all the layers of the stack. I call this as container as a service. And I have worked with many customers who literally assembled the container as a service offering, and they had to make choices for each of these layers. And what I actually notice is you're basically giving a kind of a prescriptive yet a choice of layers that can be assembled together. But one question I have, Saad, is I know these are all, some of them are open source projects, some of them are commercial, but when you mix and match, they might have incompatibility issues that might interfere with the overall cluster performance. So are they curated? For example, have you tested this specific version of MetalLB with Istio?
We do. For every single integration that we provide out of the box, today there are 50 plus, and we're adding many more out of the box. These have been all of them pre-tested with every version of Kubernetes and also across all the integrations that are available. We even go to the next level and capture metadata in terms of the constraints for the CPU and memory and storage, so that when you're adding this integration into a cluster profile and provisioning it, we're ensuring that the cluster has enough resources and capacity to even be able to deploy it. The other layer that we go deeper into is actually within the integration. So for example, when I'm adding this Prometheus stack from our public repository, you can see that there are certain fields like this admin password that is a required field. So we're even able to warn and validate to the user that certain configuration is required. And because these are password fields, we're even able to mask it. So these are something that we're able to do out of the box. And again, everything is pre-tested and pre-validated by our platform. I think one key component that you actually mentioned about our platform is the optionality. We're not locking users into a specific set of integrations or specific operating system Kubernetes. We support many different options when it comes to deploying your distributions, your operating systems, or any of the ingress capabilities.
Cool.
So jumping a little bit into maybe the bare metal aspect. So bare metal, there are two different ways of deploying. So one aspect would be, how do you deploy it on a bare metal in a data center? Typically in a data center, you would have a bare metal management interface. Think about your mask like Canonical or Tinkerbell or other platforms that exist there. For us, it acts just like another cloud environment, where you can very quickly add a cloud account for your Tinkerbell or Maz, and then using our UI or API or Terraform, provision an end-to-end cluster where we talk directly to the Maz provider and provision the VMs or provision the bare metal host, and then install the operating system and the Kubernetes on top of. I think the more interesting one is when you think about edge environments, where you typically have maybe 3 Intel NUC boxes, maybe Raspberry Pis, maybe even a single box. How do you there manage not only the applications, Kubernetes, but even the operating system? I think that becomes very, very interesting, right? So I'm going to jump into this edge stores project where I have a number of different clusters that have running across different locations. Where I have clusters running in Sacramento, in California, in Virginia, et cetera, right? Again, we provide the same level of visibility and health and metrics, how things are running across the different locations. We also have a very innovative NUC style UI that if you have hundreds or thousands of different edge locations, for you to very quickly drill down into problematic environments that may have issues, right? As you kind of scroll in, you can see how the actual cluster groups are becoming smaller and disaggregated depending on your zoom level. And if I have this one cluster in Pittsburgh that is having challenges, I can very quickly click on that as well and get all the observability data that I need to help with troubleshooting. The area that I'm going to show next is how easy we make onboarding. I think one thing that, Jana, you touched about is that in an edge environment, you don't have a lot of skilled resources. So for them, they wouldn't have any Linux experience, let alone any Kubernetes experience. You have to keep the experience very, very simple. One simple deployment model is where you actually do everything inside of your distribution center. So if you're thinking about like a McDonald's or similar use case, where they are shipping these Intel NUC boxes or Raspberry Pis to the different edge environments, in the factory, you would flash the operating system, you would set up the actual Kubernetes and even the applications, and then you would ship those boxes to the actual edge locations. The instructions for a store manager would be plug in the power cable, plug in the Ethernet cable, set up the actual box. That's all they have to do. In other environments, you may not be able to customize each and every box at the factory setting. You may only be able to install a common Bootstrap image, but the experience for setting up the actual cluster needs to be at the edge location. But even there, you want to keep it very, very simple because again, you don't expect people to be able to log into a box and SSH and run some commands. So the demo that I'm going to be showing is using a QR code where somebody receiving an Intel NUC box, what their experience looks like. So in this step, I'm going to switch on my camera phone so you can see what I have on my desk. Give me 1 second. So this is next to my laptop here, I have an Intel NUC box that has an HDMI cable that is connected to my laptop so I can see it as a monitor. I also have a network cable that is connected into the computer so I can get an IP address. I'm going to go ahead and power on the box. Okay, and what you're going to notice is right here we have the Intel NUC box that is powering on. And it has my grub settings in about 8 seconds. So, and again, the experience should be very customized. There needs to be nothing in here that talks about Kubernetes or Spectral Cloud, because for most people, they wouldn't have understanding on how to operate that. So let this go through its initial boot sequence. And after it gets an IP address, what you'll notice is, because this device wasn't pre-registered at the distribution center, it's going to be prompting a QR code saying, hey, I need to be registered. So the person, at the actual location, like a restaurant or a hospital, would essentially use their phone to scan this QR code, very similar to what you would do at a restaurant. And then the application that comes up is a very simple web app. In a second. It is a very simple web app that comes up that is more specific to the edge. So whether this is a hospital application or a restaurant application, obviously this application can be very easily themed and customized for your experience. But notice that nowhere in this app do we talk about Spectral Cloud or Kubernetes. So whatever fields and attributes that they may need to customize, they would see here. The appliance ID, which is the hardware ID, is pre-registered inside of this app itself. And then I can pick a specific store or hospital or location. So if I click on a store, I can maybe pick Milwaukee and then click on submit. And then once I click on submit, a second. There it goes. Right, it's going through and registering the actual appliance. Now, my job as a store manager is done. I don't have to ever log into Spectral Cloud Palace to see what's happening. But behind the scenes, an IT operations person can, of course, log into our console and see what is actually happening. So one, notice that this new Edge Milwaukee cluster is currently in a pending state. If I switch into a map view, we'll also see a new cluster currently being in gray, being in pending provisioning state in Milwaukee. And then if I log into the actual cluster here, you'll see that it's already importing. And not only is it going to be importing, when the actual node fully comes up, it will have your version of your operating system, your Kubernetes, any applications you define automatically attached. It's from a person doing the operation. It's keeping it plug and play and super simple. Whether you have a small box like an Intel NUC box, you have Raspberry Pi ARM devices, or you have much larger boxes, the experience is identical.
Pretty cool. I really love the idea of a QR code. I think it's going to remove a lot of friction from bootstrapping clusters and onboarding these devices. Because the QR code is almost becoming the universal way of scanning and immediately getting connected to a URL. So I think this is a very innovative way of registering and onboarding devices and managing the fleet.
Yeah, thank you, Yanni. I mean, we hope that, and obviously QR code is going to be one easy way for people to be able to manage the fleet and manage it. If you do pre-registration, then you can use our APIs, which are completely open. You can use Terraform, or using our UI. You can also register devices there. And I know we're running a little bit short on time, but just real quickly, all the capabilities that you see for our cloud managed clusters, whether it's data centers or in the actual public cloud, same capabilities from being able to run scans, running your backups across all your different namespaces, even downloading troubleshooting logs that you can send to your support team to help them manage and troubleshoot the clusters.
Awesome. So, Saad, as an industry analyst, I keep track of what is going on in the cloud native ecosystem. And today's announcement by Spectro Cloud is pretty interesting and intriguing. So what exactly did you launch, and what's the news?
Yeah, absolutely. So today we're announcing our Palette for Edge edition. Many of the capabilities I showed you today, from our NUC style UI to managing with profiles and edge environment, those are going to be available in that. We are also announcing a new distribution for the edge. It's called Palette Extended Kubernetes Edge, and is highly customized and optimized for edge environments. You talked about how you can't just use a generic operating system at the edge locations because it might be too heavy or have too many processes running. Even for Kubernetes, you need to have a distribution that is small, it's secure, and is hardened out of the box. And so we have our own distribution called Palette Extended Kubernetes-Edge that we're releasing into the field. The other big announcement that I want to also talk about is that this entire platform of our Palette Extended Kubernetes Edge is powered by an open source project called Kairos that we're leading and open sourcing. The release of being able to manage the entire system from the provisioning aspect to all the updates is going to be done in Kairos. One thing that I also forgot to mention is how we do updates, right? Because update management is for applications is relatively easy. You go through, deploy a new version of your Helm chart, you have a new pod that comes up. That's pretty easy. But what happens when you have to do an update for your operating system level or for your Kubernetes? How do you prevent this drift protection? What our platform does, both inside of our Palette Extended Kubernetes as well as in Kairos, is an immutable operating system. You will actually bring in your own OS, whether you want to bring in your Ubuntu, your OpenSUSE, your Red Hat, and we could make the entire file system read-only and only allow certain directories to be persisted across your different upgrades. When you perform an upgrade, where you go from Ubuntu version 18 to version 20, we will actually get the update as a new container image that we flash onto the B partition. After the image is flashed to the B partition, our bootloader will reboot the actual operating system. If it's able to boot into the B partition correctly, life is good. If there are any challenges, it's not able to boot properly, it will automatically roll back into the A partition. Again, we talked about resiliency is key because you don't want to be in a situation where due to a broken upgrade, thousands of your edge clusters are completely down. If you're able to provide resiliency, automated resiliency, right, that's the key for making sure you never have any downtime for your applications.
Great. The last I heard about something like this was CoreOS, but looks like this is CoreOS capability for any distribution, for any OS.
That's the key. Any distribution, whether your distribution is for your operating system or even for your Kubernetes. Obviously, we provide our hardened version, our secure optimized edge image, but if you want to bring in your micro Kubernetes from Canonical or even bring in SUSE's K3S, we can also bring this in too.
Awesome. Can't wait to play with it. It looks very promising.
Awesome. So I know we have a couple of questions. Let me just kind of go through and ask them. Okay, so maybe I'll ask this one to you, Yanni. So how is AWS Wavelength different from other edge cloud integrations providers like Cloudflare, Fastly, and CoxEdge? Have you played around with Wavelength at all?
No, I haven't used Wavelength, but Wavelength is basically Amazon's. It's almost like a zone that is living inside the telco facility. So in a lot of ways, that is the multi-access edge managed by AWS. So if you're familiar with AWS, there is a region, and within the region there are zones, but these zones are within the same limits of the city. So a Wavelength typically extends this further into multiple other cities in the same location or in the same continent, same country, but instead of running its own data center, Amazon deploys their infrastructure inside a telco facility. And that facility becomes a new zone, and that is the Wavelength zone.
Awesome, awesome. Another question that came up is using Avasha's KubeSlice, which is a virtual Kubernetes cluster, and I believe that one is more of a networking solution that bridges to provide a virtual Kubernetes across different disparate locations. In your mind, Yanni, do you recommend having a single Kubernetes cluster that spans across multiple different locations or geographies, or do you recommend having clusters that are individually isolated and providing federation at a layer above that?
Yeah, absolutely. So, Kubernetes is not designed to be geographically distributed because of the dependency on XD and the latency. The way it is designed is to work within the same subnet or across multiple subnets of the same network, but you cannot really distribute a single cluster across multiple locations. It is not really meant for that. But having said that, with something like a management plane, like Palette, for example, or Rancher, you can technically bring all of them into a single fold and you can treat them like one large cluster. But they are still independent clusters running autonomously, as in they have no knowledge of each other, but you surface all of them into a single console, single management plane, and do updates at scale. For example, you want to roll out a patch, you can select all the clusters that you want to update, push a button, and you can actually patch. That is a better mechanism than physically distributing your cluster across multiple locations.
Yeah, absolutely. Makes sense. There is a question, at which stage do you choose the actual Kubernetes distribution? So as we were showing previously, in the cluster profile, you select the operating system first, and then the second layer is where you select the actual Kubernetes distro. So out of the box, you can use the Palette Extended Kubernetes distribution, or for Edge, you can pick Canonical's Micro Kubernetes or K3s. The reason you didn't see in the demo flow was because we went to the QR workflow, which is a end user who's essentially powering on the box and going through registration. They would not know which distribution to choose. That would have been done by the IT ops team or platform engineering team building out the profile. And I think we have a few more questions, which we'll try answering offline. We'll send emails, and thank you for all the great questions. But I think we can wrap up the webinar Future of Edge Kubernetes. Please do visit our website, spectralcloud.com, to learn more about the Palette Edge announcement. From the marketing website, you can also download this Kubernetes research report that looks at how different operators are using Kubernetes at the edge today. If you're interested in also trying out the edge capabilities, we do offer a free version of Palette that's free forever, that you can very quickly self-service sign up and try out the entire platform yourself. And finally, our Twitter handles for both Yanni and myself are available here. If you have any questions related to Kubernetes, Edge, or anything related, please do ask us. Thank you so much for watching, and big thank you to our guest, Yanni. Really appreciate it. And thank you, everyone.
Thank you.